Good morning, students. Today we're looking at isotopes. Now, last lesson we looked at what defines an atom. So we looked at an element can have a number of protons, and that makes it that element. So for example, hydrogen has one proton. That means it is a hydrogen atom because of the number of protons. The number of electrons, if it's the same as the number of protons, it becomes a regular atom. If it has more electrons than protons, it is called negatively charged. If it has less electrons, it is positively charged. So you could have helium, which has 2 protons. If it has 1 electron, that makes it positively charged because it has more protons than electrons. This is called an ion. An ion. So we have cations and anions. Today we're looking at isotopes. That's when the number of neutrons changes. So an isotope is the focus, our goal today. Can you define an isotope? Can you calculate the number of neutrons and the mass number for isotopes? And that's your success criteria as well. You can do those 2 things. So write this down. An isotope is an atom that has more or less neutrons within its nucleus. Much like how an ion, which I just described, has more electrons or less electrons than the number of protons. So it becomes positive or negatively charged. Isotope is it has more or less neutrons. So it's got for example, we could have a helium which has 2 protons. It could have 2 neutrons, or it could have 3 neutrons, or it could have 1 neutron. These are the 3 different isotopes of helium with different numbers of neutrons. To look at this, you look at the periodic table, which you guys should have, or if you just look up ptable.com, and we can figure out the isotope using the atomic mass and the atomic number. So that's in the second dot point. The atomic mass represents the average mass of all the isotopes. All right, let's have a look at an example. We have oxygen. Its atomic number, or the number of protons, is 8. Its symbol is O. The atomic mass down the bottom is at nearly 16. So it's got 1 isotope, or most isotopes of oxygen have 8 protons and 8 neutrons. Together, you add them to make that number 16. Some of the isotopes of oxygen have 8 protons, again, but some of them have 7 neutrons. So you will get a number, atomic mass of 15 for those isotopes. So if you read that dot point, it's pretty much saying what I just said. There's also, this is the example of hydrogen. So to figure out what is some of the isotopes, you do that bottom number minus the top number. So 16 minus 8. Carbon is a very common element to have carbon 12, carbon 13, carbon 14. And this has to do with carbon dating, which we'll talk about later. Carbon 13 has 6 protons, 7 neutrons. Carbon 14 has 6 protons and 8 neutrons. So I'm hoping that's making sense. If you want to have a go at the activities now.